Hello, Earth Science. I want to talk to you today about how we're going to classify igneous rocks. So igneous rocks are rocks that are formed by a volcano, or at least by magma. So we have two ways to classify them. One is based on the minerals that make up the rock. So as you remember from class, we said that minerals are the things that make rocks. So rocks have many minerals in them. Minerals do not have many rocks in them. And the other way is where the rock formed. So did it form outside the volcano? We call that from lava. So lava is magma that moves from inside the volcano to the outside. Or did it form inside the volcano? From magma. Magma stays inside the volcano. So first let's start with the mineral composition. So some of the minerals you just saw in your lab are pinkish color, some are white, some are brownish, but they appear lighter with some white in there. So you could imagine that if I took these minerals and put them into a rock, that the rock might be light colored. In fact, it might even be like white and pink with a little bit of tan in there. And that refreshingly ends up being true. You put light minerals in a rock, you get a light rock. Some of the minerals we looked at were dark, like this. So you can imagine if I put dark minerals in a rock, I might get a dark rock. And that turns out to be true. So we have names for these in earth science. In fact, we call them mafic if they're dark. Like these guys are mafic minerals, so they're going to make a mafic igneous rock. So this would be an example of a rock that might be made from mafic minerals. If you put light-colored minerals, and that's a little dash of pink in there, we call them felsic rocks. So mafic are dark-colored rocks. Felsic are light-colored rocks. Now, if we put those in there, we might end up with an igneous rock that looks like this, for example. Or if we were to put, well, let's just leave it at that. So we might end up with something like this. Mafic rocks tend to have a lot of iron and magnesium. You don't have to write that down right now because it's in your reference table. I'll show you where in a different video. Felsic rocks tend to have a lot of silica and aluminum in them. So that's one way to classify it. We can say a rock is mafic or felsic based on the minerals that make those rocks up. Let me give you some more examples of some of these. This is a felsic rock. They might say, well, wait a minute, that has some black in it. That's okay. Dark-colored minerals can be part of a felsic rock as long as the majority of the minerals are light-colored minerals. And in this case, this is a speckled rock, but there's more white and gray in it than there is black. So we're going to go ahead and call it felsic. Show you an example of a mafic rock. This one. Are there light colored minerals in here? Yes, I can see them right there. Would I call this rock light colored? No, I wouldn't. I would call it mafic. There's more dark colored minerals in there than there are light ones, so we call it mafic. Another way that we can classify it on top of these, and I hope I don't confuse you by drawing on what's already here, is we can classify them based on whether they form inside the volcano or outside the volcano. So rocks that form inside a volcano. A little diagram here. Little volcano. I think you know that volcanoes go down into the Earth's crust. And sometimes lava comes out of a volcano. If you form inside a volcano, like in this area here, you have time to cool slowly. So anything that forms in here is going to cool slowly. When nature has time to cool slowly, it likes to make big crystals. So things that form inside a volcano have big crystals. When you go from a warm environment to a cold one quickly, you are going to cool faster quickly, and you're going to have small crystals. It's kind of like if you were asleep on a Saturday morning and your parents said, "Hey honey, it's time to get up soon. We're going to Grandma's house today." And you were like, "All right." But you're allowed to lie in your bed and doze, and kind of your mom or dad or whoever prompts you a couple minutes later, "Honey," you're like, "Yeah, okay," and you drift back off to sleep. You slowly wake up, versus if your parent came in the bedroom and ripped your blankets off your bed and said, "Get up right now, we're late to go to Grandma's," you would wake up fast. And because of that, you might have a jarring start to your day. These guys had a very jarring start, these rocks here, because you went from a really warm environment to a cool one really fast. And the faster they cooled, the smaller the crystals. The more slowly they cooled, the bigger the crystals. So we have names for this. Things that cool inside with the big crystals we call intrusive igneous rocks. The things that cool fast outside the volcano we call extrusive igneous rocks. So let's take a look at both. Now, the other thing is, you can be extrusive and mafic, you could be extrusive and felsic, you could be intrusive and mafic, and intrusive and felsic. So, what I'm drawing on here, I don't want to confuse you, but I'm going to just, for fun, I'm going to put another line here. I'm going to call these guys extrusive, just for fun, meaning like everything in here is extrusive. And I'm going to call these guys intrusive, meaning that this whole column here is intrusive. And they could also be mafic and felsic, so we have like 4 little quadrants that we can put these in. So, take a look here. This rock here, if you can see the crystals, and I can see individual crystals with this, I can see them sparkling back at me. If you can see the crystals, that means it's intrusive. Now, this one has more light-colored minerals than dark, so it's felsic. It's intrusive and felsic. Sorry for that smudge right there. This one, I can see crystals. You could probably see them sparkling in the light of the classroom. This is intrusive, but it has more dark minerals in it than light, so I'm going to call it intrusive mafic. This one here doesn't have any crystals. In fact, this one has little gas pockets. It cools so fast that the gas that was coming out of the volcano with the lava got trapped inside the rock. It's pretty cool. This thing here, with these little gas pockets, is going to be extrusive, and it's definitely more light than dark. So I'm going to go ahead and call it felsic. Extrusive felsic. This guy here similarly has gas pockets, cooled very, very quickly, but it's more dark than light. So it's extrusive and mafic. We're going to build on this as we go, but I want you to understand the basics of this, the different ways we can classify them based on mineral composition and also how fast they cooled. Super fast cooling rocks are going to have gas pockets and can even appear to be glassy, like this. You may have seen this before. This is obsidian. Any of you Minecraft players out there from that game, you probably know obsidian. This cools so fast it turns glassy or into glass. If you can see speckles, if you can see them, like this rock here, I can see speckles. Those are crystals. This cooled intrusively. More light than dark. It's going to be felsic, intrusive, igneous rock. So that's how we classify them, and we'll do some work with the reference table the next time that we chat.